Hello everybody. I'm Rashmy Patwari, and I want to share my journey into intelligent personalization today. So, basically, in short, it is the same personalization what we've been doing all along, but just add some zinc factor to it, and that we are going to do it by having the ML server, and so that's the plan. So let's go right into it. So here's the agenda for this session. So we're going to look at so this is a particular use case that we're going to work with. That's customer segmentation. And then we're going to take a look at what exactly customer segmentation is all about. Then we'll look at how machine learning and clustering algorithm help us into doing customer segmentation. We'll take a closer look at the architecture of Sitecore Cortex and what it has to offer what are the flavors of Cortex that we're going to use to get this personalization done in an intelligent manner. And a brief look into the case study for this demo. We're going to look at the solution. So it's not going to be just just slides. Where we are going to have a live demo where we are going to see it all in action, and then I can finally discuss any questions that you may have. So what is customer segmentation? So in short, it is basically the things that we marketing teams have been doing in a custom, I mean, in a way, in a manual manner all along. So basically, we have a large base of customer base, and we want to, identify certain factors with which we want to kind of classify our customer base into segmentations. So segments, basically, customer segments. So we can use geographical factors, or we can use very simply categorized based on gender. In this case, what we are going to use is we're going to use a marketing technique wherein the characteristics of recency, frequency, and the monetary value. So basically, it means how recently customers have been interacting, engaging with our site, how often they do that, and what is the monetary value for each engagement. So this will help us. So why do segmentation? So basically, segmentation will help us in reducing the waste in the marketing campaigns. So if you know exactly which customers are similar to each other, you will better position to target your campaigns at the right people. So in this example, what we're going to do today is, so basically I want to run a promo, and so I have a segment of customers who are my VIP customers, and then everybody else. So for everybody else, I would want to encourage them, show a promotion to join the VIP club. And for the VIP customer, I simply want to, kind of welcome them for being VIPs. So for being our esteemed customers. So basically, I mean, customer segmentation has historically been a very challenging and a time-consuming task. It will be like hours of manually pouring through different tables and querying the data, and hopes of finding some similarities, and classifying and hoping that it's all right. But with the advent of AI and machine learning, this challenging task can be fairly done very easily. So machine learning models can basically process huge amount of big data, as we call it, huge amount of data, and quickly discover patterns that are, and then categorize them based on the identified features. So in many cases, machine learning algorithms can help the marketing analysts do this job, and it can, I know it's not going to really replace human intuition, uh, but I think it does a fairly nice job, basically reducing the tedious aspect of the work. So a quick look at what AI and machine learning has to offer. So just on a technical note, basically AI, machine learning can be broadly classified into supervised and unsupervised learning. You would have definitely seen these graphs in many places, but just a quick wrap up on the knowledge part. So basically, supervised learning is based on the models trained with a tag data set. So basically, like the classification and regression are the two types of algorithms that are applied here. So we work with a prior knowledge, and we work with the some idea as to what the data set is about. When it comes to unsupervised learning, here the data is neither classified nor tagged, and it actually lets the algorithm do the job. So the algorithm will act without guidance. So in here, clustering and segmentation are the types of algorithms. So having said that, what it essentially means that over time, these algorithms are going to get trained better and better based on the data for a particular system. So for customer segmentation, I use clustering, which will actually segment the customers into groups. So let's see how we can achieve that. So the algorithm that we are going to use for customer segmentation is called k-means clustering. So what this essentially means is, so basically, as you can see from the graphs over here, we start with unsegmented or a big data set with which is not being classified yet. So what we are going to identify is center points for that data. So basically, the algorithms follows this flowchart over here. So we provide it the number of clusters. Now again, number of clusters is not like you can start with a random number. Most cases we use at least 5 clusters. So we start with that number and we place random centroids. So basically 5 center points. All the data characters what we have identified will be will find a closer point to the identified centroids, and then we actually go through this whole loop until we come to a point wherein it's called convergence. So basically what it means that we have literally identified the exact number of clusters, and no amount of training is going to change anything in this cycle. So there won't be any shuffling between the data, and there won't be any new centroids being identified. So overall, this machine learning will be very effective for us to perform customer segmentation. And let's see how that's going to happen. So where does Cortex fit into this picture? So we fairly understand what the algorithm is. We want to use it to help us segment our customer base. So let's understand what Cortex has to offer in this whole picture. So on the broad scale, basically Cortex offers us these following flavors. We have personalization suggestions, which come automatically out of the box by running A/B testing. We're not going to look at that today, but we're going to look at the other 2 points. So we'll look at content tagging, how that's going to, again, the out of the box solution by hooking in open class Refinitiv, open source system engine, and getting the content tagged using natural language processing. We will also look at machine learning, basically the framework that is provided to us by Cortex, and how we can process our XTB data into our main task for today, which is segmenting customers. So we'll just look at points 2 and 3 today. So yeah. So here's what Cortex is looks like. I mean, the workflow. We've seen this diagram in the documentation. So again, just a quick recap. On the top over here, we have our all familiar XDB, and then we have the XConnect service to process the data in and out of the systems. So now we have an additional service, the Cortex processing engine, which is again the machine learning integration tool, which will help us plug in an external machine learning server to train and evaluate our data. So what is the core of Cortex? So the core of Cortex is called the Site Course Processing Engine, which is a new ASP.NET Core based job of XConnect, and it works as a Windows service or an Azure job. It is completely scalable. It can be integrated with the task manager from the content management instance, and it integrates with the message bus. So with this understanding, let's move on to the architecture for today's demo. So I did as best as I could do to represent this in a block diagram. So it looks overwhelming, but I'll try to dissect the layers and give a fair understanding what each of these blocks mean. So over here, what we have, the first one is the website, then we have the XConnect, and then we have the Cortex processing engine, and then we have the ML server. So these are the 4 big blocks in this architecture. So our goal is to basically get data into the XDB, and as so in this use case, what we're going to do is we have the online retail publicly available data set. So we're going to feed all that data into the XDB. So each invoice would essentially become a purchase outcome, and it will be stored as an interaction into the XDB. On in here, so the website basically has to do just that. So provide interfaces to get data into the XDB, and also to demo interface which would be used to run the task chain and get it all into action. So over here we have the projection, the Cortex processing engine, which has a task chain which will do four major activities. One would be projection, which is getting data out of XDB into a tabular structure, which the ML server can understand. Then it's going to be, since the data can come from multiple sources, we need to have a merge worker, which is going to merge them all into a single data set. So train worker is going to use that data, and then we're going to see each of these workers in greater detail when we get to the code part. And lastly, we have this ML server, which is going to provide the intelligence, and it's going to do the core work of basically training a model based on the data that we provide from the XDB, and making some predictions. So when we have a new customer, so basically identifying the cluster or the segment where the new customer is going to land. So that's the job of the machine learning server. The processing engine itself has a processing database where it keeps all the tasks and worker information, also the schemas and the temporary data store. So when it runs through the tasks. So we will take a look at the demo over here, and we'll see how that goes. So in the beginning, so like I already said, so basically we have the first task was to get the XDB filled with the online retail data set. So that is already done. So I've already run the task, and the XDB is all updated with the online retail data, which is fed as interactions. So that means that the next task would be to start the ML server and let it wait for requests. So I'm going to do just that. So that's my ML server. Clear that and then start it. All right. Okay, so switch the window so that we see the action activity that's going on. So right now it's just waiting for requests. So let us give it a request, make a request to start the task chain, wherein all the workers that we have seen, the models, the workers, those are going to kick into action. So I'm going to invoke a command, a request. So before the ML server gets into action, let's go ahead and take a look at the Habitat Home. So what I've done for this demo is basically I've taken the Habitat Home site, I've upgraded it to 10.1, and I've plugged in the Cortex processing engine functionality into it, which was going to do the. So basically, the idea was to, you know, give a demonstration of how easily or effortlessly, if the architecture follows the Helix principles, it will be fairly easy for us to plug in our extra Cortex processing engine into the existing websites and get that extra intel that we seek. So in here we have so let's look at, so basically what is the processing engine. So processing engine basically has it works on models, it has some workers, and it has got options dictionaries. So in here, so this is the basic the interaction model. Like I said, we are going to work on two sets of data. One would be the interaction data that is in the XDB, and basic contact information. So in here we have the interaction data, which is going to be projected into a tabular structure. We're going to call it purchase outcome, and that's going to have the flat invoice details straight out of the transactions. Then the next model would be the contact model, wherein we are going to basically focus on these three characteristics: the recency, frequency, and the monetary value. And also, we are going to have some basic other information like the contact ID in the email. So these two are going to. So next, let's look through these briefly. Look through these options, the models as well as the task chain workers. So the basically the options dictionary contains the information about the worker, the information that the worker requires to do its job, about the model, and about the storage and the data schema. So all that is configured over here with the as the model each model's training option. Now, these in turn are used by the workers. So again, there are two types of workers over here. We have the deferred worker and we have the distributed task worker. So the projection worker is the distributed one. So is the evaluation worker. So what that essentially means is that they're going to parallelly work on chunks of data from the data set and using cursors. So if again, one thing to remember over here is like if the data set does not support parallel read, then we may want to switch to deferred workers. So that's the task of the projection worker. So since the data over here, it may seem a bit of an overkill, because so why do we need parallel reads when we are actually working with just one single source of data, or why do we need a merge worker? But when we have disparate sources of information, data coming in from different sources, from legacy systems or different sources, then the merge worker has an important role to get it all together into one single data set in a one single table. So then we have the train worker, which is going to be the main link between the ML server and the processing engine, and hence the website. So that's where all the magic of the drama happens. So basically, the train worker is going to interact with the ML server. At this point, let's see what's going on the ML server side. So there it is. So the train already took its time in doing kickstarting the workers, preparing the models, fetching data out, and then issuing a request to the ML server. So it's actually requested the ML server to train its model based on the characteristics that we have supplied. So it's the ML server is basically trained its model, and it's sitting ready now. And very soon it's going to start the whole cycle of predicting the cluster information for each of the contacts that we have in the XDB. So at right now I have about 4,000 contacts worth of information in the XDB. It's going to take me approximately 10 minutes. We can take a coffee break at this point and come back. It's really late for us on the East Coast. Okay, never mind. So since I have already done this algorithm several times, my data set is all updated with the cluster information. So we can go right in and check what's happening on the site side of things, or how exactly the homepage looks with the intelligent personalization. So I don't want you guys to wait for 10 minutes to see it all in action. So I'm going to fire up a browser. Again, like I said, it's a well-known habitat website, and I have just added an additional promo over here for so like right now I'm anonymous to the site because I've not yet logged in. So that's the reason we have this promo, which is encouraging me to join the VIP group and get more benefits. So I'll keep this here, and then I'll start one more window wherein I will log in, and then we'll see how the promo is going to react to me. So this is basically one of my VIP customers, and once this customer logs in, yeah. So Bridget Jones is my VIP customer, and now let's see how the homepage will look for Bridget Jones. So there it is. So it is basically catered to the VIP customer. It knows, it identified her as a VIP customer, and it is just going to, have a different promo altogether. So what is the link now between, we saw the ML part, we saw the part wherein, the way the Cortex processing engine and its workers are interacting with ML. So the missing link is, how did all that intel come into the site? So how did the site make use of that intel? So in here we've used basically rules, and then I've used pattern cards. So basically all the different categories of customers basically are categorized into 5 clusters. So VIP, and then regular, and somebody who is literally on the verge of leaving our business. So so you get the idea. So basically, so let's go and look on the Sitecore side of things, how this is kind of brought together. So in here, so that's the 10.1. Okay, this always has to happen in demos. Get logged out. There. So that's the promo, and we look at the personalization part of it to get an understanding as to how this all came together. So it's a very simple rule that's working over here. So if the contact is a VIP, then we show something. Otherwise, for all other default conditions, we show just the promo where it is encouraging people to join the club. So how does the rule look? Now the rule is, so that's the rule for me. And basically, if I look in here, I have these different pattern cards created for each of the, for the different customers that we have in the system. So that's being used, and that's the personalization element of the demo. So this is what I mean. It may feel nothing after all the effort that has gone behind the scenes to get it to this point. But once we have this, system, so this is a very simple use case of personalization that I've demonstrated over here. But literally, like, there are unlimited possibilities of what we can do with this piece of information that we got from running an AI algorithm. And so basically all our campaigns can be specifically catered now to, like, we can confidently cater them to the groups, to the segments of customers that we have got, rather than doing in a trial and error manner. So there it is. So while we are here, I would like to switch gears and look at the other aspect of Cortex that I had mentioned in the agenda. So basically, we are going to look at tagging as well. So let's go to the content editor and tag a few pages and see see the different tags getting populated. So this is a standard our good old habitat home site. So this is an SXA website. There are subtle differences between the way SXA handles tagging, as well as how the other classic websites do it. So I'm going to choose a page, an item, and so I have not tagged this item yet. So let me go ahead and just do that. Okay. So I've got these 4 tags, which are, I didn't do anything special to get this intel into the system. The system is automatically, it is capable to give this functionality out of the box by using the Refinitive's open class system, the intel from that system. So basically, so this is how, so we can go ahead and try another node and another item as well. So we have 2 options here. We can even tag the item and its sub items. I'll try that now. It'll take a bit longer, while is the entire tree of items is going to get tagged together. So what advantage do we have by doing tagging? So basically, content tagging will help us in augmenting our searches. Also, this is quite a tedious task for content editors to identify tags in the whole content and having it populating this. So there are certain. So let's look behind the scenes over here as to how exactly this whole tagging is configured. So I'm going to go back to the Habitat Home site and show you just that. So basically here we just have two configurations to be done. We need to create a perm ID with the Refinitive's NLP system, and we have to configure that token into this thing. So that's all it takes to enable tagging on any website. So the other thing being, we can also, I mean, there are a lot of possibilities here. This is just a beginning where, just how to get started kind of message. But beyond this, we can swap engines. We can, instead of the out of the box one, we can have more, I mean, there are a lot of good examples and work that's out there in the community, which actually gives us an idea as to how we can have custom tagging, as well as different other tagging options, how to do image tagging based on the reading the images. So a lot of good work out there. So basically in here I've simply modified the fields to specifically choose a set of fields rather than go with the default that comes out of the box. So that's pretty much it. Also, when we go back in here, so basically certain subtle differences between how SXA does it and how classic websites do it. So SXA has its own tagging. I mean, it's a slightly different mechanism. So it also stores its tags right here and with each site. So we have data in the data folder. We have all the tags stored together in an SXA site, whereas classic sites do it in the system folder. Similarly, again, SXA sites have all the tags right here in the tags field, whereas classic sites will have it in the semantics field. So that's the difference. So with that, I've come to the demo part. I mean, come to end of the demo part for this showing intelligent personalization. And let me see what else is there on the presentation. Okay, so there's some great references over here, which I had, which are they're like a lot of, like I said, a lot of great work on Cortex, as well as content tagging in the community. So that helps. Also, so this is something. So even this is a good read, just to understand what customer segmentation and machine learning is all about. So that's the data set I have used for the demo. So I had to quote something. So this is basically kind of wraps it up. The understanding that we got. So basically, we can go a lot deeper into providing relevant content out there. We can make good use of Cortex to get that done. Right now, AI is already out here, which is actually going to do all of this straight out of the box. But then Cortex gives us more flexibility if we have some if we want to decide on different algorithms and bringing in some domain specific AI into the systems. So that's about it. Yes, I am indeed a proud member of the community, and I can be easily reached at the usual hangout spots. So reach me out in case it will be very nice to collaborate and go one step ahead into the work that's set out. So thank you all for your time, and I really enjoyed preparing this presentation for SUGCON. And do reach out in case you have any questions. And I guess it's time for questions now.
Thank you, Rashmy.
Thanks, Rashmy.
We're looking light on questions again here.
Yeah, just going through chat. Most of it tends to revolve around whether it's beer time or coffee time. I can't see any specific questions there.
Oh, it's cold here, just tell you.
Just leave a couple of seconds, see if there's any last-minute questions come in.
Have you had a look at some of the new AI features, Rashmy? Some of the newer stuff?
No, I haven't. That's next on my list. So I do understand that. I mean, it's going to do basically the same thing that this demo aims. So basically, it's going to do a customer segmentation into known clusters of information based on the understanding that we get from the system. So it's out of the box. So I need to get my hands on that as well.
Couple of comments. Rich Seal, Dylan Young. Thanks for the talk. Nice talk. So, thanks, guys, for that.
Now is the time for solidarity in the face of this threat to all of humanity. I implore leaders to stand together and heed this appeal.